Lesson 3.2 is on the graph transformation theorem. Last year in Advanced Algebra 2, you studied the graph transformation theorem, and your teacher should have given you a purple note card. We're going to look at that purple note card just a little bit differently this year because we know so many more additional functions that we can talk about. So I've kind of redesigned that purple note card. You should have that and your lesson master and your graphing calculator, and then we'll be ready to begin this lesson. The first thing we're going to look at on the graph transformation theorem is the graph translation theorem. And you might recall what translation means. Translation means that we are going to slide or move, sometimes we call it shift, the graph, and that would be left and right and up and down. And so the first problem they want us to consider is the equation of y equals x minus 3 quantity squared plus 7, and they want to know what is the translation rule for that. Now, we know that we can take the graph and we can move it to the left and the right and up and down, and we can write the equation, which is what we were given right here, but they want us to work backwards and find the rule. And so this will be a little different than how you learned it in Advanced Algebra 2. For translation, we're going to use the big capital T. And that should be the same as how you learned it in geometry. And then the x comma y is going to tell you that every ordered pair x comma y is going to move somewhere. And it's going to move based on what's happening in this equation right here. So if we think about this equation, you might recall that anything inside the grouping symbol, like this x minus 3, will actually go the opposite direction of what you think. So this would actually move the graph 3 to the right. We'll move it 3 to the right. And then this plus 7 that's outside will actually move the graph 7 units upward. Okay? And so when we go to write the rule over here, the rule will be absolutely what's happening. So we want to make the rule so that we move the graph 3 units to the right and 7 units upward. So in the rule, we're going to say x plus 3, comma, y plus 7. X plus 3, y plus 7. The easiest point to track on that graph would be what happened to the ordered pair 0, 0. So that was in our parent graph 0, 0. And now we're saying that that's going to move 3 to the right and 7 up. So we'd want to make sure that it goes up here, and the new vertex point is 3, comma 7. So I could do that by putting that in my graphing calculator over here. I could say x minus 3 quantity squared plus 7, and I'll just graph that on a little Zoom 6 window. And then we can check it over here. We can trace the point 3 and see if it does indeed come out to be 3, 7 at that new vertex point. So when you're writing the rule, what I want you to remember is it'll do exactly in the rule what you want it to do. That's the rule is going to guide you. Then when you go to put it in the equation, anything inside of a grouping symbol we're going to have to change and make it be the opposite of what you think it's going to do. Okay, the second problem shows us we have this rule given to us. And so since this is the rule, when you read the rule will tell you you're going to move it 4 units to the right and 3 units down. So it says apply this rule to this parent function over here. Okay, and I'm going to jump over here to the purple note card for a second and talk about these parent functions over here. So these parent functions are the ones on your pink note card. Last year in Advanced Algebra 2, you worked exclusively with lines, parabolas, and the absolute value function. And we worked over and over and over again on moving those functions left and right, up and down, and then doing the vertical and horizontal shrinking and stretching of them. Okay, well now, after last year, we know all of these parent functions. The identity, the parabola, the greatest integer or the step function, the cubic, the hyperbola, the inverse square, the square root, the absolute value, and the exponential. We actually know a couple of others too, like logarithm from last year, but we're not going to deal with that just now. We're going to just use these 9 right here. And out of these 9, we can move we can do the translations, which would be step number 2 on your purple note card, or we can do dilations, we can do reflections on all of these functions. Okay, so it's going to be a little different than last year in that respect. But what I wanted to point out would be that you can have a lot of different grouping symbols. you're used to parentheses and absolute value bars. But you could have your square root symbol, your cube root symbol. This is supposed to be like a little fraction bar like you would have on your hyperbola, your inverse square. You could have any of those grouping symbols, and you would need to know that for that grouping symbol, anything inside that grouping symbol or that has to do with that grouping symbol is going to go the opposite direction of what you think on the horizontal sliding or the horizontal translation. Outside the grouping symbol, it'll do exactly what you want it to do. Alright, so keep that in mind when we're working on this problem. Don't be confused about this translation rule. The translation rule is just, it's going to have a grouping symbol, it's going to have parentheses around it, because it's actually telling you exactly where that graph is going to go. Alright, so the rule has parentheses around it because it's talking about the ordered pairs. The ordered pairs. Okay, so if I want this to happen to my little cubic function, I'm going to start out with y equals, and then I'm going to make parentheses and put my x in here and put my cube right here because I'm cubing this. This is that little graph of that snake graph, right? The cubic function. And I want it to go 4 to the right. So to get it to go 4 to the right, I'm going to put a -4 right here. This will go 4 units to the right. And if I want it to go 3 down, then I'm going to put -3 out here. So what that means is this point 0, 0, if I started with the point 0, 0 and I applied the rule 4 to the right and 3 down, then that ordered pair would become 4, -3. And then my graph would be moved 4 over and 3 down, so it's still going to be a cubic, but it's going to have the point of inflection right here at 4, -3. And we could check that out on our graphing calculator over here by taking parentheses x minus 4, which will take me 4 to the right. And I'm going to cube that, and then say I want to go down 3. And so I'm going to graph that, and then I'll check my little point of inflection over here. My point of inflection, is it truly at 4, -3? And it is. Okay? So that's what we have to do when we have the rule. We have to look at that rule and say, the rule is going to guide us and tell us everything that we need to do or where we need to go. It's like follow the rule. You have to follow the rule. Okay, so in this rule right here, this rule says we're going to go 8 to the right and 10 down, because this is your horizontal translation and this is your vertical translation. So they call them H and K, don't they? We're going to apply that to the absolute value graph. So we're going to say f of x would equal, and inside my grouping symbol I want to go 8 to the right, so that's going to be x minus 8, and then I want to go 10 down, so I'm going to say minus 10. Alright, so if we think about the parent graph, it would look like this. The absolute value graph goes through 0, 0, and you can check that out by using your pink note card. We want to go 8 to the right and 10 down, and then we want to have that graph look like this, so that this point is 8 to the right and 10 down. Okay, well let's check it out over here. You might remember to get the absolute value bars, we need to go to Math, and then over to Num, and then absolute value is the first choice right there. Alright, we're going to do x minus 8 because we want to go 8 to the right, and then we want to go 10 down. Let me set my window just a little bit lower here so we don't go just on the edge. Okay, and the graph looks like this, and that vertex point is at 8, -10, isn't it? Okay, now the next one's going to be a little bit more challenging because this is an offspring of the graph of y equals 4 to the x. So it's that y equals a b to the x. This is an exponential problem. And what you're going to notice about this is what we've done to this. It wants us to write the rule, and they gave us the equation. So you have y equals 4 to the x minus 3, and then you have a minus 5 right here. Now I want you to look at that, and I want you to say, well, in your mind you're thinking, I don't see a grouping symbol. If you were going to type that in your graphing calculator, though, let's say you want to put it in your y1, you'd have to type 4, and then a caret, and then you'd have to put parentheses around the x minus 3, wouldn't you? And so that is where your grouping symbol is right up here in that exponent. And so I can see that I'm going to take that 3 units to the right, and then my minus 5 is going to be 5 units down. Alright, so when I go to write my rule, I'm going to say I want this big capital T, every ordered pair, x comma y, and I'm going to tell what happens to every ordered pair here. Well, every x unit is going to go, or every x coordinate is going to go 3 to the right. That's x plus 3. Every y coordinate is going to go 5 units up, so that's y plus 5. On this one, we'd be tracking, remember your parent function here? Your parent function of the exponential would go through 0, 1, because anything to the 0 power is equal to 1. 4 to the 0 power is 1. We'd want to track what happens to the point 0, 1. We want it to go 3 to the right and up. Oh, 5 down. Sorry. A little mistake here. 5 down. We've got to have a minus 5 there. We want to go 5 down. Okay, so that means that this would become the ordered pair 3, negative 4. All right, so let's try that on our calculator. Let's graph that and see if that comes out to be at 3, negative 4. So we'll have 4 raised to the power of, parentheses, this is our grouping symbol, x minus 3. And then remember, I messed that up over here. I want to go down 5. So I'm going to say minus 5. I'm going to graph that. This will be an exponential function. And I want to see if it goes to the ordered pair 3, negative 4, and it does. So that used to be this ordered pair up here that was at 0, 1. It's been moved 3 over and 5 down. Okay, on number 5, it says we're going to write the graph of the parent function, y equals 1 over x. So this is our hyperbola that's translated 3 units to the left and 4 units down. So this is kind of like my rule right here. It told me my rule in words. I want to go 3 to the left, 3 to the left, and 4 units down. Oops, y minus 4. Okay, that's my rule. Or I could write it this way. My big capital T means I'm going to go 3 to the left and 4 units down. 3 to the left and 4 units down like this. Okay, so if I want to write the equation, okay, write the equation of that so we can graph it, I'm going to say y is equal to 1 over, and then this is where my grouping symbol is going to be. If I want that thing to go 3 to the left, I'm going to say x minus, oops, I'm going to say x plus 3. That'll take it 3 to the left, and 4 units down, we'll say minus 4. So that'll go 3 to the left and 4 units down. And then it says, give the equations of the asymptotes. Okay, well here's the deal. Whenever we have the hyperbola, the parent graph of the hyperbola, the vertical asymptote is right here at x is equal to 0. It's this line right here, isn't it? And so if I take my vertical part of my graph and I move it 3 units to the left, that means that my asymptote is going to move 3 units to the left as well. So my new vertical asymptote, I'm going to abbreviate that VA for vertical asymptote, will be at x equals negative 3. Then this minus 4, we'll see where my horizontal asymptote is. The horizontal asymptote right now is at y equals 0. It's going to get moved 4 down. So it's going to come down here, and it's going to be, I'm going to use HA for horizontal asymptote, it's going to be at y equals negative 4. Okay? And, oh, sorry about that. And so now I want to graph that over here, and let's see then if we can write our domain and our range. All right, so if you wanted to, you could put this on your calculator and you could look at it on the calculator. Let me type it in here. It's going to be y equals 1 divided by, and then we're going to use our grouping symbol, and we'll have x plus 3 to get it to move 3 to the left, and then 4 down, we'll have a minus 4 right here. All right, so let me just graph that. I'll just put that back on our Zoom 6 window and we'll graph it. So it still looks like a hyperbola. And that would fit on the Zoom 6 window, wouldn't it? So you can take your straight edge. I'll get my pen right here. Okay, and we'll divide our graph up over here. I'll just say that I'm using this 10 by 10 window. And I'll kind of mark off where 5 is. Okay, so 1, 2, 3, 4. Okay, I'm going to put a vertical asymptote at x equals negative 3. Now the asymptotes are not really part of the graph, so I'm going to write those on as dashed lines here. They're just used to help guide me so that I don't accidentally cross over it or touch it. Okay, and then I need to locate negative 4 on my y here. I think I'll put negative 4 about right here. And I'll put my horizontal asymptote on here. I'm not using my ruler because it's difficult for me to do that with my stylus pen, but you could use your straight edge for that. Okay, so now that we have that marked off, we can draw that hyperbola. Now we might want to check. This goes through negative 3 and 2/3 down here. And then we might also want to see where our x-intercept is. I happen to have a line at y equals 0 here, so I'll just move my graph over in this neighborhood and trace that point. So I can get it accurately. It's negative 2.75, isn't it? So this comes down here and then turns and goes like this. So this ordered pair was negative 2.75 comma 0, and remember our y-intercept was at, let's see, wrong line, at 0, negative 3 and 2/3, like so. Okay, I better graph one more point on this other branch. Something to the left of negative 3, I'll just pick negative 4, and we're at negative 4, negative 5. So we get a nice comprehensive graph right here. Okay, now that we've got that figured out, let's go over here and write down what our asymptotes, but our domain and range was. In the domain, we're going to skip negative 3, because that's a vertical asymptote. It's terrible looking infinity symbol. And then in the range, we're going to skip negative 4. Okay. So that is that problem, and we got all the parts of it done. Okay, now we're going to work on everything from the purple note card. So identifying the parent function, analyzing the transformation using the 4 steps at the bottom of the purple note card, and then writing the transformation in a complete sentence using the order on the purple note card, and then sketching a simple sketch and label the transformation to point 0, 0 or to 0, 1 on the sketch. Okay, so I want to go over the whole purple note card for you just so you make sure you understand all of it. And I'll also look at it in terms of the pink note card as well. Okay, so the first thing it says you're going to do, number 1, is you're going to reflect over the x-axis. So that's the first thing you want to look for. If the function or the graph has been reflected over the x-axis, that means that this, I wrote the basic graph as y equals a times bx minus h plus k, where h and k are your horizontal and vertical shift, and your a and b are going to be your scale factor. And we'll study those things individually when we study, there's a lesson on scale factor and there's a lesson on translating data a little bit later, but you need to get used to those letters A and B and H and K. Then I wrote you a bunch of grouping symbols here. So we're saying if this number in front of the grouping symbol, a number out in front of the grouping symbol, the coefficient would be negative, then that means you're reflecting over the x-axis. The next thing would be the translation, and for the translation you'd be looking at the shifting or the sliding of the graph. That's going to be your H and your K. The third thing will be the dilation. For the dilation, I said ask yourself this, is the number inside the grouping symbol or outside the grouping symbol? Inside or outside? The B number is inside and the A number is outside the grouping symbol. If it's outside and the A number is greater than 1, we're going to have it be vertically stretched. If the A number lies between 0 and 1, which means it's a fraction or a decimal, like 1/2 or 2/10 or something like that, we would have vertically compressed. If we're talking about the B number inside, we'll have horizontally compressed if the B value is greater than 1. I said absolute value because there could be a negative sign inside there as well. And then horizontally stretched if it's a fraction number between 0 and 1 or a decimal number. And then last but not least, we have the reflection over the y-axis. If the B value inside the grouping symbol is negative, then the parent function will be reflected over the y-axis. So keep those rules handy because we're going to look for certain things based on that position of y equals a, b to the x. Now notice here I just wrote grouping symbol of parentheses. Our grouping symbol could be any of these things. It could be parentheses raised to the second power, third power, fourth power. It could be absolute value. It could be the square root symbol, the cube root symbol, the fraction bar. Could be any of those things for the grouping symbol, and they certainly could have powers on there. So don't be confused that that this is just for linear, because this looks like something that's just linear. Okay, so for number 6, what we're going to do is we're going to write down step number 1. And step number 1 is just going to be to identify the parent function. So the parent function is y equals the absolute value of x. And then I'm going to number my paper 1, 2, 3, and 4 right here. And we're going to identify those things. We're going to look for them. So do we see a negative sign outside the grouping symbol? And the answer to that is no, so we don't have a reflection over the x-axis. The second thing we're going to look for is the translation. And so for the translation, I'm just going to write my big capital T. I see that I have a +1 inside the grouping symbol, which means this will go 1 to the left. I have a +7 outside the grouping symbol, which means it'll go 7 up. So I want to keep that written this way so I can say it's 1 to the left and 7 up. Okay, for number 3, do we have a dilation? Well, I have no coefficient number outside, and the coefficient of x on the inside is a 1, so we don't have that. And for number 4, we don't have a negative inside, so we don't have that either. So I'm going to come down here and write my sentence. My sentence is going to say, the graph of y equals the absolute value of x has been, and then I'm going to tell in this order what has happened. So ours will be translated 1 unit to the left and 7 units upward. So this is the answer to the problem when it says write the transformation in a complete sentence. And now I'm going to draw my little simple sketch. And so for my little simple sketch, I don't have to get out my, my plastic card that I gave you, like a credit card size thing, and draw around it. We're just going to draw it on here as a simple sketch. Okay, so it would be going to -1, 7. It's an absolute value graph. It's going to open upwards, so it's going to look like this. And this will appear right here will be at -1, 7. So make sure you label that point. Okay, let's try number 7. On number 7, parent function is the cubic y equals x cubed, so that's going to be that little snake graph, right? That little snake graph. And we're going to write down what's happening here. Okay, we do have a negative sign. We don't have a grouping symbol. We have a negative sign out front here. So that's going to be reflection over the x-axis. For the translation, I don't see anything in a grouping symbol, but I see this -4 right here, which means this is going to go 0 to the left or right, but it's going to go down 4. Okay? As far as dilation goes, this would be like a -1 in front of that, so we don't have to worry about anything happening there with the shrinking or the stretching or compressing, anything like that. And I don't have a grouping symbol, so I don't have to worry about anything inside the grouping symbol. So we're just going to write the graph of y equals x cubed has been, and then we're going to say translated. No, we're not either going to say translated. Sorry about that. We are going to say reflected over the x-axis, because that's what comes first, and translated 4 units downward. Here's our sentence, and then let's make a picture of that. If we took that snake graph and reflected it over the x-axis, it's going to go back this way, isn't it? And then we're going to move it down 4. So it'll snake back through this way, and it'll go through 0, -4. If you ever have trouble with that and you want to confirm that, then you come over here and you type in exactly what the problem was, and you look at this graph, and then you trace the point that you have here, which would be 0, -4. Okay. On number 8, the parent function is the line y equals x. So it's our linear function. We don't have any grouping symbol this time. We don't have a negative in front, so we don't have anything here. The only part of translation we would have is 4 units up Okay, but we do have a 3/5 in front of the x. So since it's technically outside the grouping symbol, since there is no grouping symbol, we're going to say that we have this vertically. And then remember, if it's a fraction between 0 and 1, it will be compressed. And then that would be by a factor. We're multiplying, so it's a factor of 3/5, and then no reflection over the y. Okay, so we're going to say the graph of y equals x has been translated 4 units upwards and vertically compressed by a factor of 3/5. So this is what our answer is. How does that look? Well, it looks like it goes through 0, 4 right here, and it's got a very, well, not as steep a slope as your identity function. Your identity function is going to go right through here with a slope of 1. It doesn't quite have that much slope, does it? So this is 0, 4. Okay, number 9. Parent function is the parabola y equals x squared. Notice that we don't have any negatives outside the grouping symbol for number 1. For number 2, now this is where it gets kind of tricky. Some people like to say, well, now wait a minute. Maybe that 2 is a positive 2 and not a negative 2, but set this aside. Don't worry about this for the time being. Just look at the x plus 2 part. That's going to go 2 to the left, and then this is going to go 8 down. Okay, we don't have any vertical horizontal stretch, but we do have a reflection over the y-axis. That's what that negative sign inside that grouping symbol is going to do, is reflect that over the y-axis. So we're going to say the graph of y equals x squared has been translated 2 units to the left and 8 units downward and reflected over the y-axis. Alright, so this is what we think is happening. So let's see what that would look like. Okay, we're going to take our vertex point at -2, -8, so it's like right here. And we're going to reflect it over the y-axis, which means it's going to come over here and be at the point 2, -8, isn't it? And then the parabola is going to open upward from there. Alright, so let's see if that's true over here. We're going to take parentheses, the opposite of x, plus 2, and then we're going to square that, and -8. So let's see what it looks like on the graph. Let's see where the vertex is. Is it at 2, -8? And it is, isn't it? So we had to do this translation first, though, and find this point, because this was telling us go 2 to the left, and this was telling us go down 8. And then we used reflection to get us over here to positive 2, -8. Okay, number 10. New wrinkle and a new twist here. Parent function is y is equal to x squared. And then, okay, we have no number 1. For number 2, we're going to go 2 units down. For number 3, we now have a horizontal and then this is going to be, because this number is a 4, and then we're squaring that number. Okay, so we have 4 squared, which is 16. 16 is greater than 1. That makes it a compression. In other words, if you multiply that out, you'd have 16x squared minus 2, and this would be super skinny. It'd be like taking our parabola and pushing it in on both sides horizontally and making it really, really, really skinny in here. So it's a horizontal compression by a factor of, and it's 16. Now you might want to know why it's 16. Well, this is being squared. If that had been our cubic polynomial, it would be 4 cubed. If it was our absolute value function, it would just be by 4. So you're going to have to watch what function you have, because that function might have a power. Could be the square root symbol, and that would only be by 2, because the square root of 4x would just give you the square root of 4 would be 2. So you're going to have to watch that and be very careful. If that's inside the grouping symbol and there's some power, whether it be a fraction power or an integer power, that's going to be affecting it. Okay? And then none of this. So we're going to say the graph of y equals x squared has been, and we'll say translated 2 units downward and horizontally compressed by a factor of 16. So it's going to be a pretty skinny little graph here. So let's see what happens. We would move it down to 0, 2, or 0, negative 2, and then we're going to make it really skinny here. So this would be at 0, negative 2. Okay, let's try that over here and see what happens. I put parentheses 4x, and then I square it, and then I say minus 2. So it looks like a pretty super skinny little parabola there. It does, doesn't it? Okay, so for number 11, you don't even see a grouping symbol in this problem. But if you were to type it in your calculator in your y1, you'd have to type in 1 divided by, and this is where you would put the grouping symbol, isn't it? So let's put a grouping symbol around that, and let's name that parent function. It's the hyperbola y equals 1 over x, isn't it? Okay, and then if we do our steps 1, 2, 3, and 4, we have just the only thing we have is the translation. It's going to go 2 to the right and up 6, isn't it? 2 to the right and up 6. So we're going to say the graph of y equals 1 over x has been translated 2 units to the right and 6 units upward. Why 2 units to the right? Because there's a grouping symbol that's implied right there. Okay, so if you want to make a picture of that, we're going to come over here and we're going to take those, remember where those asymptotes are on the parent graph? The asymptotes are the x and y axes. I'm going to move this asymptote 2 to the right. I'm going to move this asymptote 6 units up. Move the whole graph up here. And then I'm going to draw my parabola on here. Okay, so this is where 0, 0 used to be. And 0, 0 is now at 2, 6, where the asymptotes meet, isn't it? That's where the asymptotes meet. Okay, so same as last year, but also a little bit different. Would you agree? Same but different in that we have a lot more functions that we're looking at, and then we also are working a lot more with the horizontal shift. Okay, I'm going to have you pause the video, and I'm going to have you do 12 and 13 by yourself. And then when you're done doing those two, I want you to put the video back on, and then we'll see if you have the same thing I have. Okay, let's take a look at number 12. On number 12, the parent function was y equals x squared. It had a reflection over the x-axis due to this negative sign right here. It had a translation of 5 to the right and up 3. It had a vertical stretch by a factor of 2. And so what's going to happen is we're going to have this ordered pair 5, 3, which probably is not going to scale very well. And we're going to have it a little bit skinnier since it has that vertical stretch. And this just means that it's going to open upside down. Okay, opening downward. Number 13, the parent function was the absolute value of x, and so this one had a reflection over the x-axis right here. It had the translation of 4, which was inside the grouping symbol, so 4 to the left and down 3. Vertical compression by a factor of 1/2 because that number is outside the grouping symbol and it's a fraction, so that's outside, and a fraction would be vertically compressed. And then last but not least, we have this negative sign for reflection over the y-axis. So this just means that it's going to be the V-shaped graph opening down. I located where I thought the point 4, -3 was, and then I reflected it over the y-axis here, and this just means it's going to open up wider than normal, okay? A little bit wider than normal. Okay, so far so good. pause the video and do 13, or do number 14 and 15. They'll be a little bit more challenging to you because they're functions that you're not as familiar with. But do 14 and 15, and I'll meet you right back here, and you'll see if you can agree with what I have. Okay, let's talk about number 14. The parent function is y equals the square root of x. It's been reflected over the x-axis due to this negative sign right here. The translation is 4 to the right and up 5 due to these two numbers right here, and had a vertical compression by a factor of 1/3. So, you know, the parent graph of the square root of x looks like this. So if you reflect it over the x-axis, that's just going to turn it down this way, isn't it? So we turned it down that way. We moved it 4 over and 5 up to right here. And then we had that vertical compression, which means it's not a very steep function anyway, but it flattened it out a little bit more, so it looks something like this. Okay, and then on the one that was, I wrote the parent function was y equals 2 to the x. If you wrote y equals b to the x, that's fine, but this is going to be an offspring of 2 to the x, so I would take either one of these, but it is exponential growth. The only thing it had going for it was this is where your grouping symbol would be, which makes it go 3 to the left and 4 down. So if we think of the ordered pair 0, 1, which is on the parent graph of that would go through 0, 1, because 2 to the 0 power would be 1. If you took that and you went 3 to the left and 4 down, then you'd be at -3, -3. So that's this point right here. Now the other thing is this has the horizontal asymptote at y equals 0. And this would move that horizontal asymptote down to y equals -4. So I put that little horizontal asymptote on there as a dashed line, and I show that my graph is going to get close to that. Like if I keep going out this way, it'll get closer and closer and closer, but it won't touch or cross over that amount. Okay, so I think you're ready to do number 16, and we'll see how we go on number 16, and then I'll meet you back here, and then we'll do number 17 together. On second thought, I think I'm going to talk you through number 16 a little bit here, so hopefully you don't waste too much time trying to do it yourself. 16 has a feature in it that's different than all the other ones that we've done so far. You could tell right here that you are going to get a reflection over the x-axis, can't you? And now you try to do the translation, so you're probably thinking 8 to the left and up 5, but you've got a little problem inside here in that you've got 2x plus 8. And so what we're going to have to do with this one is we're going to have to set that and factor out this 2 right here. We're going to set that 2 aside. So if we factor out a 2, we'll have this. We want to look at the translation with an x right here. I'm going to show you up above here. See how you were always looking at 1x minus 4 or x plus 3, or if I go up a little further here, you had not minus x plus 4, 1x minus 5. You were always looking at that with a 1 right there. Well, now we're looking at that with a 2 right there. We have to get the translation when we just have 1x right here. So the translation of this is going to be 4 to the left and up 5. Okay? Then this 2 right here becomes horizontal, doesn't it? And since 2 is greater than 1, it's a horizontal compression, isn't it? So it's a horizontal compression. I mean, it's just going to be pushed in horizontally or thinner. And that's by a factor of 2. And then we don't have this, do we? Okay, so what this means is we're going to be upside down, we're going to move it over, and then it's going to be skinnier, isn't it? It's going to be skinnier. So let's see if we can find that. If we went to -4, 5, it'd be about right here. Reflect it over here. So then we would be at 4, 5, and then we're going to bring that down like so, kind of skinny. Okay? So it would be the graph of y equals the absolute value of x that's been reflected over the x-axis, translated 4 units to the left, so it's still 4 units to the left, and 5 units upward, and then the horizontal compression by a factor of 2. We get to 4, 5 through the reflection over the x-axis and the horizontal compression. So let's see if that's right. Let's graph that one and see. We'd have the opposite of, and then I'll get my absolute value here, and then inside of here I'm going to put 2x plus 8, and then the plus, let's put the plus 5 on the outside. And so if we graph that, okay, something happened here. Oh, okay, I know what happened here. I'm just being stupid, aren't I? Okay, I'm only reflecting this over the x-axis. I'm not reflecting over the y. Why did I do that? Whoa, baby. Here, let's go back this way. It's still going to be back this way, and it's going to be at negative 4, 5. Sorry about that. I don't know why I thought I had this when I said I didn't have it. It's only reflected over the x, not the y. And so it would be at negative 4, 5, wouldn't it? Okay. 17 has a similar situation right here with the 5, but it also has a negative sign right here. And so this one's going to get even trickier. Okay, let's start with our parent function. So it's the parabola, isn't it? Okay, it's the parabola. All right, and then let's write our 1, 2, 3, 4. All right, well, we can clearly see we have a reflection over the x, which means it's going to open downward, doesn't it? Okay, I have to get this to be a 1x. And so what we're going to do, put a big parenthesis here and a big parenthesis here. Inside this set of parentheses, I'm going to factor this. But what we want to do is we want to set this negative aside, as that all that's doing is the reflecting over the y-axis. All right? And we just want to factor this part right here. So if we just factor this part right here, we'll say 5 parentheses x plus 6 more, and then a minus 2. All right? And I'm going to graph this over here so you can see what I'm doing too. I'll graph this original problem, so parentheses, negative 5x plus 30, already squared, minus 2. Okay, I kind of wanted you to get a feel for what this is going to look like here. Okay, so we have a little skinny parabola over here whose vertex, okay, so we think the translation of this would go 6 to the left and down 2. Would everybody agree? 6 to the left and down 2 here. And then we'd have this 5 right here, which is a horizontal compression by a factor of 5, meaning it's super skinny. Okay, and then we have that reflection over the y-axis. All right, so if we made our little picture of this, what happens is we're going to open upside down, and this is going to make it very thin, very thin. I'm going to start at negative 6, negative 2 right here, reflect that over here until we're at 6, negative 2, and then it's going to open down super skinny from that, and that's what happened. If I trace on this and I go to 6, 6 will take me to negative 2. Okay? So, and this is it's even skinnier than that in the picture, isn't it? So that is really tricky. You'll have to set this negative sign aside. Just set it over here, forget about it, and then just factor the rest of this. So you're not factoring out a negative 5. If you did, then that would turn that into a negative 6. We have to get this point over to here and say that it goes 6 to the left and down 2 before it gets reflected over the y and become positive 6, negative 2. So that kind of breaks a factoring rule or two in there, but you have to set that aside. You'll have 1 or 2 of those to do in your homework, so you're going to have to come back and look at this example from 16 and 17 and kind of look at what you do with that factoring and how you get that x to be a coefficient of 1. Okay, and then they want to know if you can go the other way, and so to do that, looking at taking the sentence that's already written and writing it back into the equation. And you maybe will have to write these things down in that order so that you can understand them, or you might be able to go y equals and just make yourself a big grouping symbol, whatever grouping symbol they give you here, and then do what it says here. Translated 4 units to the right would be x minus 4, wouldn't it? Vertically stretched by a factor of 2 would be outside. Reflected over the x-axis would be a negative outside, wouldn't it? And shifted 3 units downward would be outside the grouping symbol. And then you could graph that, and you could say, well, did what my graph that, or my equation that I made up, did it do what I thought it was going to do? Well, I don't know. Let's see if it does. And then we'll go x minus 4, and then a minus 3. So let's graph that, and let's see if we think it does what it's supposed to do. Okay, was it supposed to be reflected over the x-axis, so it was supposed to be upside down, and upside down v. Okay, and so for my upside down v, then I have this 2 right here, which says it's going to be skinnier, and then it's going to have a vertex at 4, negative 3. So 4, negative 3 upside down and skinny. Let's see if that's true. If I trace the point 4, is it 4, negative 3? And it is, isn't it? Okay, so for number 19, let's just start with a big grouping symbol with a square here. It's going to be shifted 3 units to the left, so that's x plus 3. Reflected over the y-axis, so ooh, that has to have a negative sign inside there. Shifted 2 units upward, vertically compressed by 2/3. Vertically compressed by 2/3. Okay, well let's see if that happens over here. If I put in 2/3, parentheses, the opposite of x plus 3, and then I square that, and I say plus 2. Graph that, and let's see what it looks like here. Okay, well first of all, the 2/3 compression is going to make it wider, isn't it? Okay, we thought the vertex was going to be at negative 3, 2, but it's not at negative 3, 2 because that got reflected over the x-axis, over the y-axis, and so now it's back here at 3, 2, and then it's opening up and it's kind of wide. So let's check the point 3, 2 and see if we're right. And we are. Okay, I'm going to let you try number 20 and number 21, and then you can just meet me back here when you think you're done. Be careful because you've got a horizontal compression, and you know that number has to go inside the grouping symbol. So be careful on these last two. Okay, so it looks like I made a ginormous grouping symbol here, but it turned out there wasn't anything else to put in there. Now check it out. Horizontally compressed by a factor of 25 means that if I squared that number, so when you're doing your 1, 2, 3, 4 over here, when you got to number 3, this would be horizontally compressed by a factor of 25, wouldn't it? But you only put a 5 right there, don't you, because that's being squared. Reflected over the x-axis means a negative sign out front, and then you have up 9.9. So what would happen if we made a picture of this one? Well, it would get moved up 9.9, it would open upside down, and it would be super, super skinny, wouldn't it? Let's try that and see if that's true. If I had the opposite of 5x, and then I squared it, and I said plus 9.9, super skinny, vertex is at 0, 9.9, isn't it? Okay, so be careful of that because that horizontal compression is inside that grouping symbol. Okay, and this last one here, it had to go 4 to the left, 16 upward. So here's my 4 to the left, here's my 16 upward, reflected over the x-axis, so I got that negative there, and then horizontally compressed by 5. So I put the 5 here, and I put parentheses on it. So I set this aside so that it could go 4 to the left and 16 up, and then I went ahead and distributed this and said, okay, it would look like this. So it would be negative, or it would be 5x plus 20 inside there. So let's see what that would look like. So I'd have the opposite of the absolute value of, choose that, and I'll say 5x plus 20, and then a plus 16. Okay, so I'm going to need a slightly bigger window for this. So, because what did we say is going to happen here? This is going to go 4 to the left and up 16. So I just need to get some more height on it, and it's opening downwards. Let me just move this to 20, and I think that should be good enough to see it on there. Okay, so did it go 4 to the left and up 16? Well, let's check it out. 4 to the left and up 16 it did. It's opening downward, and it's been horizontally compressed by a factor of 5. Okay, so there we go. All right, so your assignment then will be to do your homework from 3-2. You can use this as a guide. You can always come back to the video if you need to. Your purple note card will be invaluable to you. You may also want to keep your pink note card handy so that you can look at those parent functions and the shape of them, so it will help you with your sketches, but you can also use your graphing calculator. So good luck with that, and if you have any trouble, please come and see me.